So part 3, so the same circuit, we've got a light bulb, we've got a capacitor, and now we're using this as the inductor. Part of the reason of using this as an inductor is that you can have an iron core, and so it's brown wire into the light bulb, across the capacitor, up to the inductor, from the inductor through the Vernier Ammeter, and then brown back into the power supply. And so we're seeing I'm drawing voltage in live time, and I can push collect on my ammeter, and I can see I'm getting about 0.1 amps, and then as I decrease the frequency a bit, the bulb's ever so slightly coming on, and if the bulb's coming on I expect the current to be a bit higher, so it went from 0.18 now to 0.23, and we're seeing that that's also getting higher, so the voltage across the bulb, and as we change the frequency a bit more and that bulb gets even brighter, we're seeing that that wavelength gets smaller and the height gets bigger, and so we'd also be expecting the current to get bigger. And so yeah, at 0.3 amps, so at resonance we're expecting the highest current, and I can just change it a little bit more. Then we can see it's got a bit smaller, and this has got a bit smaller, and then as I decrease frequency more, the bulb goes out. We're seeing that wavelength's got bigger and the amplitude's got smaller, and we should see the same thing happening here. That the amplitude's getting smaller, and so we're seeing that current does really, maybe it's better if I just drop off like that. Current does really drop off when it's not at resonance, so 0.1 amps. So how's that set up? So that ammeter goes into the LabQuest, which then USBs in. I'm sampling it 100,000 samples for 0.1 seconds. It needs to go through the LabQuest, not over Bluetooth when you're doing such huge sampling rate. I could have done the same thing, instead of using the oscilloscope, I could have put the Vernier voltmeter across the bulb. So if we go back to resonance, there, and then I show the effect of removing the iron core. Oh, that wasn't very effective. Okay, now I've actually got it at resonance. It wasn't quite at resonance, it was a bit too low before. So now at resonance we can see a really high voltage across my bulb, and as I add the iron core, you're seeing the voltage on the oscilloscope go down, and we're seeing the brightness of the bulb also go down. So the bulb's off with the iron core in, and so what are we doing? We're essentially changing L, which is changing, or it's moving where the resonant frequency is. So it's increasing XL, which means that XL and XC are no longer equal, so it's changing that frequency. So that's a cool little demo as well, and so you can show that on your ammeter and your voltmeter, but the oscilloscope does voltage in lifetime, which makes it a bit more effective than the ammeter, which I haven't been able to get a multimeter ammeter or an analog ammeter to measure current well because of the inductance that has. That the ammeter actually affects the resonant frequency of the circuit. Cool.